In 2015, NASA astronaut Scott Kelly began a unique mission to spend nearly a full year, 340 days, aboard the International Space Station, ISS. But this wasn't just any mission. Back on Earth, his identical twin brother, Mark Kelly, remained behind, living a normal life. Since they shared the same DNA, NASA saw a rare opportunity to study how space affects the human body by comparing the two brothers. During his time in space, Scott's body began to change. Without gravity, his spine stretched, and he became about 5 centimeters taller. But this was only temporary. Once he returned to Earth, he shrank back to his original height. More surprising were the changes inside his body. Scientists found that Scott's telomeres, the protective ends of chromosomes linked to aging, had actually grown longer in space. This was unexpected. However, after his return, they shortened rapidly, possibly speeding up aging. NASA also studied how Scott's genes behaved. They discovered that although most of his gene activity returned to normal after the mission, about 7% of his genes changed permanently. These changes were related to his immune system, DNA repair, and bone health. Mentally, Scott faced challenges too. After nearly a year in isolation, he showed signs of slower cognitive function, such as reduced reaction speed and focus. But what about time itself? According to Einstein's theory of relativity, time moves slightly slower for someone in orbit. Because of this, Scott technically aged a few microseconds less than Mark. In other words, after returning to Earth, Scott was just a little younger than his twin. This experiment, called the NASA Twin Study, gave scientists valuable insights into how space travel affects the human body. It will help prepare future astronauts for long missions to the Moon and Mars, and maybe even beyond.